So, hello everyone, myself Abhishek, and these are my teammates Durva Badade and Giriraj Gavit. So, we are presenting a case study situation in an electric scooter company, and there are a scenario based questions below, and we will address it one by one. The first question is what are the some of design considerations you would have for designing the storage feature, and what all will you need to consider for security of the documents while designing the architecture? So first of all, we'll focus on the securing document upload with the encrypted channels. For example, if the vehicle contains face ID verification to unlock the vehicle, then we need to encrypt that photo of the user should be encrypted. Then it should support PDF, JPEG, and PNG formats accessible via mobile and tablet. Security includes end-to-end encryption, multi-factor authentication, and role-based access controls. Also, audit logging and intrusion detection. Keep tamper-evident logs of critical events, such as if any sensor records any critical events, it should be logged in the database. And monitor for abnormal patterns like rapid unlocks, high-speed errors, and trigger alerts. Next is API security and throttling. Securing the backend APIs with OAuth 2.0 and JWT, enforcing scopes and short taken lifetimes. Rate limit APIs to prevent data scraping or brute force attacks. Backup and disaster recovery. Implement encrypted geo redundant backups for user and operational data. So, if any disaster happens in a floody regions, so their backup should be ready. And second, last is device level security. Secure scooter onboard controllers with firmware signed by your backend. Store device credentials in tamper resistant module and require mutual TLS for scooter to cloud communication. So this was the first question. Moving to the second question. List the potential reasons for any two of the issues which customers have complained about, and write the test scenarios you would use to test and ensure they have been fixed. So, we have conducted a survey. In that survey, we ask user to share their issues with the electric scooters, and out of the listed issues, we have selected two, and they are unexpected battery drainage, and second is notification not updating. So in first, the cell aging and SOC errors. So old cells and misestimated charge lead to premature empty readings. Uh, Excessive background polling. Continuous GPS scan runs down the battery at idle. So these were the issues, and we conducted a test. There were two tests. First test was full discharge ride, comparing actual watt per hour use versus displayed SOC over a full ride, and there was a margin of error of plus minus 5% of the battery capacity. Second test was at ideal mode profiling, measuring idle current with GPS off versus on. In each case, we will there will be margin of error greater than less than 10%. So second is not updating the notifications. So the issue was failed data or expired tokens. Syncing were missing from Windows, and tokens were not pushing. So which delayed the notifications, or sometimes the notifications were not even updating in the user's mobile or device. So in second issue was UI refresh bug. Notification isn't rebounded or refreshed after data arrives. So we conducted a test multi-network delivery, triggering a notification under 3G, 4G, and Wi-Fi, and confirming arrival should be less than 5 seconds. And another test was token rotation and UI refresh. Expire the push token to verify auto refresh, then pull to refresh relaunch to confirm badge updates. So this was the second question. Now moving on to the third question. The company is collecting the data in the cloud already, but have had performance issues to collect the data and update the app. What can be the reasons for that, and what would need to be improved for the data integration for the from the vehicle to the cloud and send data post analysis to the app? So here are the potential reasons for performance bottlenecks: high telemetry volume and frequency. Sending raw sensor data in real time floods bandwidth and backend. So there are n number of sensors in vehicles nowadays. So they sends raw data in huge amounts. So this should be managed very well in the backend. Second is intermittent connectivity and latency. Cellular drops and high altitude delayed data ingestion. So suppose we are traveling in ghats or hilly areas where network is very less, or sometimes there is no network. So in that case, connectivity issues and latency issues were discovered. Third is synchronous processing pipelines. Blocking API calls from vehicle cloud app, app create back pressure. So what happens here is, from vehicle the sensors data goes to cloud, and in cloud there are codes running at the back end, which gives the which calculate the raw data and gives result, and it push back to the device. So and last is monolithic data store and queries. Large unindexed tables and complex joins, slow writes and reads. So here are the recommended improvements. Edge pre-processing. First is edge pre-processing and batching. We should uh, aggregate the data and filter it and compress telemetry on device before uploading. So second is lightweight pub or sub ingestion. So in decouple producers from consumers and buffer spikes. So we we know that producer consumer problem we are studied in OS. So we are very well knowing that. Asynchronous streaming pipelines use several functions or microservices with event driven triggers. Scalable NoSQL and time series database. So store telemetry in index TSDB, so for example, influx database, and serve app queries via CDN or cache layer. Okay.
Seventh question is the company would like the app to have the intelligence and provide recommendations to the driver. What kind of data should the app collect from the vehicle and what kind of recommendations can be done? Is there any possibility to use ML and AI other analysis? And if so, what can be the use cases? So for the company to collect the data, they have to also consider that they don't violate the privacy of the users or the customers. So they have to collect the specific data which will not affect their privacy. So they can collect data like the speed and acceleration patterns to analyze riding behavior, battery usage statistics uh, to get the charging cycle related information, voltage drops, and rate of battery discharge. Also, trip data, routes taken, distance traveled, and stop duration to analyze the behavior or the type of the driving the customer is using on the vehicle. Also, environmental data, temperature, and road type is if possible. That will help to determine if the vehicle is being used in a harsh conditions or normal environmental conditions. Or also charging behavior, in which frequency, duration, and location of charging can be analyzed. With that, the uh, many battery related problems can be solved if there is an issue within it. And also maintenance logs, if sensor reports and other errors are detected in the maintenance logs. Recommendations for the app to give are the app or UI can provide some interactive and catchy lines like your battery is draining fast due to high speed driving. Try keeping speed under 40 kilometer per hour or for longer range. As we know, the more faster the vehicle goes, the less the its ranges for ranges. So we can tell the customers to drive slow, so it doesn't affect the its claimed range. Also, there are other lines like you can usually charge late at night. Schedule auto charging between 12 a.m. to and 4 a.m. for lower electricity costs. Based on your driving patterns, maintenance might be needed soon. Book a service. Avoid gravel roads on route XYZ. Last last time battery overheated. So the app UI can use this type of line and notifications to uh, warn users or customers to take a specific routes or book a service or something. In in this all ML and AI can be used to predict the maintenance using past sensor data and failure history to predict the upcoming issues. Route optimization, recommending energy efficient routes based on traffic terrain and user habits. So it might need data from the vehicle like speed, acceleration patterns, and all that will be mentioned earlier. Battery health estimation, predict remaining battery life and suggest charging behaviors. Driver behavior profiling, scoring users and suggesting how to improve efficiency and safety. Also, the vehicle can integrate some safety features like if the user or customer brakes some harshly or the vehicle senses some danger or something, it may call SOS or a police helpline number for advanced safety. Personalized notifications, email can learn what kind of alerts the user actually responds to and reduce unnecessary notifications. Next question. Next question is use the product solutioning concepts and create a mind map for the new version of a vehicle explaining the goals, features, and UX and UI changes. So the goals company wants to achieve is the resolve customer complaints quickly and effectively to enhance satisfaction. So the in marketing the only the product sales is not only goal. So, improving user and customer satisfaction is also very important to attract more customers. Improve user experience and comfort for long term engagement. As I mentioned earlier, user satisfaction may lead to long term engagement with the customer and can uh, increase sales by 50% within 6 months through strategic initiatives. Achieve 10% profit per unit by optimizing efficiency and cost. The vehicle manufacturing and can improve majorly with efficiency using some other methods for manufacturing the product. Ensure no major issues in the first 3 months of strong foundation. Features features for the vehicle: the interactive tablet dashboard with vibrant display and touch support for seamless user experience. As for today's date, the touchscreen display support for most vehicles is very common. So uh, integrating that into the vehicle will attract more customers. Fast charging technology under 4 hours for maximum convenience. For as compared to the other fuel vehicles, the 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 one advantage the fuel vehicles has over the electric is the charging time. The fuel vehicles require nothing for charging, while the electric vehicles may need some time to charge. So the faster charging technology may attract more customers also. Optimize weight reduction to stay competitive in the market. The weight is also a big factor for in the market for a vehicles. Integrated Google Maps navigation for effortless route guidance. Using the phone, using any phone or other device for navigation while driving or riding is not for not suitable for safety. So within the touch screen of the vehicle, you can integrate a Google Maps navigation to enhance the user experience. Document storage via app with dashboard display for easy access. Uh, as we mentioned earlier, the user can upload its vehicle related or and own documents into the vehicle, and it will be displayed onto the touchscreen for a seamless experience. Smart app with AI-driven recommendations to enhance usability. Uh, as we mentioned in the above slide, AI-related features can be implemented to enhance user experience and usability. UX changes, streamlined initiative app layout for effortless navigation, quick access to key features with fewer clicks, enhance usability, seamless real-time sync between scooter and app for up-to-date data, hassle-free document upload for instant access and storage, personalized notification tailored to user preferences and need. So the main goal of the UX changes to uh, uh, main goal of the UX change is to enhance user experience. So the choppy UX or UI may spoil the user experience of the customers. UI changes, minimalist flat design with icon-based navigation for modern interface. As icons are most suitable for modern interface, it is recommended. A default dashboard view featuring speed, charge percentage, GPS, and alerts for instant updates. The notifications from the phone will also get displayed on the touchscreen of the vehicle if did so. Smooth swipe or a button-based interaction for effortless usability. For the touchscreen, smoothness of the and less choppiness of the display and interface can improve user experience vastly. Enlarge touch zones to accommodate gloves and rough roads conditions. As for uh, different weather-related scenarios or rainy scenarios, the uh, touch sensitivity of the display needs to be adequate enough to uh, uh, register some weight touches or and anything. Dashboard night mode for improved visibility in low light environments. So the display can integrate dark and light themes for improved user experience based on their taste. Next slide. The next question is research on the evolution of a domain of electric vehicles and represent it on one slide in impactful way on what has been the evolution and where you think it will be 10 years from now and what kind of features function would be available. So if you look at the table for before the 2010, most of the electric vehicles were in prototypes or concept era only, and for today's it is mass produced by many companies like Tesla, Ether, and Ola, and also by some Indian companies like Tata and Mahindra. For the future, com the electric vehicles may get as common as primary transport integrated in smart cities, battery and range, lead lead acid. The lead acid battery used in past vehicles uh, ha- had around 50 to 100 kilometers of range, while for today's era, lithium ion lithium ion battery can give up to 150 to 300 kilometers of range. While for future, solid state batteries and wireless and swappable options may enhance the user experience more. Charging tech for the vehicles before 2010, slow charging was a bit of a con for them. While for today's era, fast charging is available, so the vehicle can fully charge between 4 to 6 hours. And also, there are many published charging stations are available for use enhance safety and user experience. While in the future, we can assume that wireless on-the-go charging may get implemented and even 10-minute full charge. Connectivity features before 2010, there wasn't much technology available for connectivity. Features on today, apps, OTA updates, and remote diagnostics are available. And in future, even voice command, gestures, and UI full automation is can be implemented. UI interface and dashboard, basic displays, For present, smart dashboards with navigation and app integration. In future, adaptive and customizable UIs with a voice gesture controls uh, might be available. Sustainable integrations n- not considered for today's era. Regenerative baking and energy efficient focus. And for future, vehicle to grid, V2G and solar panel integration can be implemented. Smart functionality none for 2000 before 2010 era, and for today's era, real-time data and remote access via apps can be implemented. And for future, predictive maintenance and IoT/ML driven insights can be implemented. For the future direction of the EVs will not just be the vehicle but data generating AI powered energy integrated platforms. They'll be personalized, environment aware, and seamlessly connected to other systems in our daily life. I believe in the next decade, EVs will become as much about software and connectivity as they are much about transport.
Myself, Durva Burde, and I will be taking the questions 11 to 13. So we'll move to the 11th question. If you want to write detailed test scenarios for testing battery of a vehicle, what all would be the top 10 to 20 scenarios? And we can create a mind map and do a relative priority of the test scenarios based on the most important to the least important. So priority test one are the most critical, and it basically is very important to test these as they serve uh, a safety, as it impacts the safety and performance and user satisfaction. So the test will cover capacity, safety protections, environmental factors, and real world usage conditions. Um, so few of the points that we have mentioned in the presentation are validating the battery capacity. So we have to ensure the battery delivers a rated capacity. Uh, Next point we have battery charging test, time test. Verifies the charging completes within the expected duration. Uh, Next point we have thermal stability at high and low operating temperatures. So basically, we have to check that the battery functions in extreme temperatures to ensure the safety of the user. Uh, Moving on to priority two tests, we can say it stands by the assesses the standby power drain and ingress protection against water and dust. Next point is evaluates the battery voltage retention during idle impact, resistance at operational speeds, and response to low voltage conditions. The next point would be verifying accuracy and consistency of battery health, state of charge, and state of health diagnosis. Moving on to the next question. What can be very user-friendly design of the tablet dashboard UI on the vehicle? What data should it show? Draw the UI using pen and paper, submit the picture. Also write the ways in which user would use the touchscreen to interact with the UI. Comment on what UI would have by default and how the user can navigate on UI and what all functions it should have with the goal of keeping it easy to use. So key feature, we have to make sure that it is user friendly design. Um, it should by default it should show real time speed, battery status, and estimated range by default. It should also include trip data, navigation, weather alerts, and customizable settings. So the dashboard is basically the rider's control center. So it must prioritize essential information upfront while providing easy access to deeper data. We can use gestures to allow quick screen changes without distraction, voice commands, enabling hands-free safety. So we can use touch shortcuts as well, offering immediate access to maintenance or document features. The UI should basically balance a rich information with simplicity to avoid overwhelming the user. Next slide. The last question. What do you think are the business metrics which are being used by the company to decide what to focus on for improvements and changes. What engineering metrics and measurements do you think should be looked at considering the complaints from customers? Do you do also give the reasons for the metrics and measurements you have selected? Uh, Business metrics include basically the customer retention rate, customer satisfaction score, revenue per unit, and churn rate. And engineering metrics would include mean time between the failures, pass field yield, first pass yield, and battery efficiency, and software bug rate. So basically, the business metrics will measure the customer loyalty, satisfaction, profitability, and market position. These aspects will help prioritize features that drive growth. Engineering metrics will focus on product reliability and manufacturing quality, battery performance, and software stability. Key factors in reducing complaints and improving user experience. Together, combined these, they enable data-driven decision making, balancing technical and market needs. So, business metrics. First off, we have customer retention. Customer retention is basically a percentage of scooter users who will renew their subscription after 12 months. Like how many people will get back to you about the same. Next point we have customer satisfaction score. So direct feedback on user happiness and experiences taken through this feedback. Revenue per unit. It indicates the profitability per scooter that is sold. Churn rate tracks how many customers stop using the product. Engineering metrics. So, first off, we have mean time between failures. It evaluates how reliably the vehicle operates without any breakdowns. Second point, first pass yield. It is the percentage of scooters that pass quality test without any rework. Third point, we have battery efficiency. So, it is critical for improving the scooter range and uh, and its performance. Then we have software bug rate. It measures the frequency of bugs in the app or firmware that is affecting the user experience. Now, the reasons for selection of these metrics. Basically, business metrics highlights market and customer trends to prioritize feature improvements, and engineering metrics provide an insight of the product reliability, technical areas that need fixing or need fixing to reduce the complaints from the user. Now, together, these two combined, it helps align the technical efforts with business goals and customer needs. Thank you.